So welcome into my channel. In this session now we are going to talk about finding the Laplace transform using the first shift theorem. When it comes to finding the Laplace transform using the first shift theorem, the basic thing that we need to understand is about the first principle formula. And by the first principle formula, we know that the Laplace transform of our function f of t is equals to integration with respect to our limits exponential negative st, we multiply by our function f of t, and our integration is with respect to dt. For example, here now you can be told find the Laplace transform exponential at with respect to our angle here, let's say sine that. We understand that when we are using the first principle method, we are going to replace our function f of t with respect to whatever we are having there, to mean that we are going to have the Laplace transform of exponential at sine our angle is equals to, here we are going to have integration with respect to our limits exponential negative st. Our function f of t is equals to exponential at sine our angle with respect, and everything is with respect to dt. At this point now, we understand that we are going to reduce the number of exponential by using the laws of indices, whereby we are going to have integration with respect to our limits exponential in bracket negative s. Here we come and add to a, we multiply by t, and we are going to have sine our angle here with respect to dt. At this point now, when we carry out our integration and insert the negative that we always get after inserting the upper class limit and the lower class limit, you will find that our angle here, its answer is being shifted, whereby now we are going to have integration with respect to our limits exponential negative s we subtract from a with respect to here the Laplace transform of this one directly, which is equals to our function f of t, because here at some points we are going to have t, we are going to have sine hyperbolic of t, and we are going to have sine or cos t. It depends with whatever we've been given, to mean that after first you come and get the Laplace transform of our function f of t. But when you check here, it is being shifted with respect to our term of at after carrying out our integration and inserting our limits. Now let us get into our working. This is how, by using this knowledge, this is how we are going to carry out our shifting methods to the terms of s in this equation. Let us now start by our first example. In this example now, we've been told to find the Laplace transform of 4 exponential 3t cos 5t. The first thing that we need to understand, we need to get the Laplace transform of cos 5t. And by finding the Laplace transform of cos 5t directly, we are going to have s all over s squared. Since it is a cos, we are going to have an addition of 5 squared. This is the Laplace transform of cos 5t directly. It is being shifted with respect to exponential 3t. When it comes now to shifting, it is only the term of s that is being shifted, to mean that we are now going to have 4 exponential 3t cos 5t. The term of s is being shifted here. We are now going to have s. When we check here, we have a coefficient of a positive 3t, to mean that to the term of s, we are going to have a negative of 3. This is what we refer to as the shifting all over s. To the term of s, we carry out our shifting. Here now we are having a positive of 3. We are now going to have a negative of 3. Everything was squared. Here we come and add to 25. We were having the numerator, we multiply by 4. Let us now get into our second example. We agreed that the first thing we first carry out the Laplace transform of sine 3t. When it comes to the Laplace transform of sine 3t, we are going to have sine is going to be equals to 3 all over s squared. We add to 9 because we are going to have 3 squared. We do now our shifting with respect to the term of s, to mean that now we are going to have 3 all of, it is only the term of s that we do our shifting. And how are we going to carry out this shifting? We are going to have s. Here now when you check, we are having a negative of 2t, to mean that we are now going to have a positive of 2. Everything squared, we come and add to 9. Let us now get into this example whereby we agree that the first thing we come and get the Laplace transform of our function t. And by finding the Laplace transform of t, we understand that the Laplace transform of t is equals to 1 factorial all over s squared, because we are going to have n plus 1, which is going to be squared. We come and do our shifting with respect to the term of exponential. And when we carry out our shifting here, we are going to have 1 all over s. Here we are having a positive, to mean that we are going to have a negative of 4, everything squared. Let us now do our shifting here. First, we are going to carry out the Laplace transform of cos hyperbolic 4t. The Laplace transform of cos hyperbolic 4t is equals to, we are going to have for cos, we are going to have s all over s squared. We subtract from 16 because it is going to be s squared. Let us now carry out our shifting with respect to the exponential here. It is 3 exponential t cos hyperbolic 4t. To the term of s, we do our shifting, to mean we are going to have s. The coefficient of t is equals to a positive of 1. Here we say that it is now going to be a negative of 1 all over s. We subtract from 1. Everything squared, we come and subtract from 16. We multiply by 3 on the numerator. That. And this is now going to be our answer. Let us now come and find the Laplace transform of whatever we are having here. The first thing that we agreed is that we come and first get the Laplace transform directly of sine hyperbolic 2t. The Laplace transform of sine hyperbolic 2t is equals to, we are going to have 2 all over s squared. We subtract from 4. We subtract from 4 because 2 raised to a power of 2 is equals to 4. But since it was 5 exponential negative 3t sine hyperbolic 2t, we are going to have, to the term of s, we do our shifting, and we are going to have 2 all over s. Here we are having a negative of 3. We are going to have a positive of 3 when we shift with respect to that coefficient squared. We come and subtract from 4. We multiply by 5. And now there we are going to have 10. And this is how you go about finding the first shift theorem. And this is how you go about the Laplace transform using the first shift theorem.